Now let's look at our second equation, 2x plus 3y equals 0. In the previous video, we found that the graph of this equation is going through the origin as x and y intercepts turn out to be the same point. So we're going to need an additional point or additional points to graph this equation. And I only want to use points with integer coordinates. So to find them, I could plug any values for x and solve the equation for y, or vice versa, and I could continue the process until I'll find the points with integer coordinates. However, to speed up the process a little bit, I'm going to solve the equation for y. So 2x plus 3y is equals 0. To solve the equation for y, first I'm going to move 2x to the other side. And I'm going to have now 3y equals negative 2x. And now divide both sides by 3. So y equals negative 2/3 times x. So now I can clearly see that if I'm going to let x be integers, multiples of 3, plus minus 3, plus minus 6, plus minus 9, then my denominator will cancel and my y is going to turn out to be integers as well. So let's try a couple of values. If x is equal to 3, y is going to be equal negative 2/3 times 3 over 1. I presented 3 as 3 over 1. Now 3 and 3 cancel, so I'm going to end up with negative 2. And I'm going to try x equal negative 6, y equals negative 2/3 times negative 6 over 1. Now 3 and 6 could be divisible by 3. So I can cancel 3 in my denominator and in my numerator, but 6 divided by 3 is equal to 2. Now negative times negative is positive. 2 times 2 is equal 4. 4 over 1 is equal 4. So here are two additional points with integer coordinates that I could use to graph my line. I'm going to plot them on my coordinate plane. 0, 0, 3, negative 2, 6, negative 6, 4, and I will connect them with a straight line. But before I want to move to my last example, I would like to show you a slightly different approach on how to find the additional points with integer coordinates. So now let's look at our equation after we solve it for y. Here, y equals negative 2/3 x, and you probably already recognize that this is a slope-intercept form. A slope-intercept form of a linear equation is the form when the equation is solved for y, and the right side is presented as mx plus b, where m, the coefficient of the x, is the slope, and b is the y-intercept, which could be presented as an ordered pair as 0, b. Now, we already do know what the y-intercept is. Let's say a few words about the slope. Slope, often denoted as m, is the ratio of delta y over delta x, change in y over change in x, or simply rise over run. So how can I use slope for graphing? Let's say I'm given a graph of a line, and I know what the slope of that line is. Now, if on that line, I can choose any point. It could be y-intercept, it could be x-intercept, or it could be any point without any kind of preference. And I'm going to call it a starting point. Now, if from that point, I'm going to perform the steps according to my slope, meaning moving delta y units in the vertical direction, and then delta x units in the horizontal direction, I will end up at the point on my line. And again, if I repeat the steps, moving delta y units in the vertical direction, delta x units in the horizontal direction, again, I'm going to end up at the point on my line. So if I use my y-intercept as my starting point, that now I can find additional points using the slope. So First, I'm going to use this version of my slope, -2/3, which means move 2 units down, 3 units to the right. So let's start. 2 units down, 3 units to the right. So my next point with integer coordinates would be 3, -2. And I could repeat the steps now from this point. 2 units down, 3 to the right. And here is my new point with integer coordinates, 6, -4. Now, if I would like to move to the left from my starting point, I would have to use this version of my slope, 2 over -3, which means 2 units up, 3 units to the left. So again, starting at 0, 0, move 2 units up, 3 units to the left, and here is my point with coordinates -3, 2, and again, repeat the steps, 2 units up, 3 units to the left. So here is another point, -6, 4. So this is a great method to use, especially when y-intercept is an integer. I could use it actually, even if my y-intercept is a fraction. However, every time I plot a point with coordinates that are fractions, there will be an error. And then if I start moving or performing steps from that point, the error propagates, and thus the accuracy and the precision of the graph is not going to be that great. So if your y-intercept did not turn out to be to have integer coordinates, you could always try the x-intercept. But if x-intercept doesn't have the integer coordinates, then you can always hunt for a point different from intercepts with integer coordinates and use that point as your starting point. And that is what I'm going to do in my next example, in my next video.